So here with number 21, we're asked to give the domain and range of the relation. So you'll recall that domain refers to the x's. So we're going to find out what are the possible x values of this relation. And then we want to find the range, which refers to the y values. So we're then going to find the possible y values of this graph. So let's go ahead and first and foremost, let's talk about domain. So if we look at this graph here, and this is not the same exact picture that's on your test. I went ahead and recreated this graph so that we could more easily identify what's happening here. But it is the exact same relation and same stop and end points and all of that. But what we can see here is for domain, let's see, what is the smallest x value that this relation has? Well, let's see. If we go ahead and draw a vertical line right through the smallest x value, we can clearly see that the smallest x value is -3, right? This point here, -3 comma -2. And the largest x value that this relation will ever have is right here, right? Again, if we draw a vertical line, we can see that it's 0. And so this relation, its domain is from -3, the smallest value, and the largest value is 0. Nothing else exists on this relation outside of that. There are no x values smaller than -3 out here. There are no x values larger than 0 out here. It's just this tiny portion of the graph here. And so we can say that our domain is from -3 to 0. And notice that we're using brackets here, aren't we? Because we're using a number. We're including -3 as a possible value for x, and we're including 0 as a possible value for x. And now that we want to, or now that we found the domain rather, let's go ahead and see if we can identify the range, the y values. And we're going to do something similar. We're going to go ahead and look at our relation here. And this is also a function, right? It passes the vertical line test. So if we look at our function here, we can clearly see that the largest y value that this graph will ever have looks right here. And let's go ahead and if we draw a horizontal line now, we can see that the largest y value is 1, isn't it? And similarly, if we want to draw a horizontal line through the smallest y value, well, it looks like that's right here, doesn't it? And this is the point, -2, -3. And so the smallest y value that this function will ever have is -3. And so we know that this relation, this function, only exists as far as y's are concerned, between -3 and +1. It doesn't exist any greater than +1 up here somewhere. It doesn't exist anywhere smaller than -3 down here. This is it. Just this little portion in red here is all that this function is because it's been restricted, right? And so we can say then that the range, and normally we write smallest to biggest, so we'll say -3 up to +1, and that is our range. So, you know, sometimes people will get confused. These are not points. This is not -3 comma 0. This is not -3 comma 1. This is interval notation. So this is saying the domain of this function, the x's, go from -3 to 0, and the y's go from -3 up to +1. And so there we have the domain and range for number 21.